So let us discuss about the set data type in Python. Sets are basically unordered collection of objects. So by unordered collection of objects, which means that it cannot be indexed like lists or tuples. So let me try to define a set and let us try to understand what that statement means. So I'll define a set here with three elements A, B and C. So you define the set just like the list, but the only difference is that instead of the square braces you have the curly braces, and with tuples you have the parentheses, right? So I'm going to define this set1 equal to A, B and C, and let me check the type of this variable set1. So you can see that the keyword is set, I mean the data type is set. So what I told was the sets are unordered collection of objects, so which means that it cannot be indexed like lists and tuples. Okay, so when I say something like set1 of 0, which means that I am trying to access the first element of the set, which is A. So when I try to execute, if you do this on list or tuple, it's going to work, but if you do this on set and execute, you get this error, set object is not subscriptable. So which means that the set cannot be indexed. Okay, so that was about unordered objects. And one more point is that the set contains only unique elements. Okay, let me try to define one more set here. I'll write set1 equal to 1, 2, 3, 4, and then intentionally I'll again write 1, 2 and maybe 4. So I have repeated 1, 2 and 4. Okay, and then I'm writing these elements inside of a set. So I enclose them in between the curly braces, which means that I'm trying to declare a set here. So now after entering the values, if I check the values of this set object or set variable, you can see that all the unique elements have been removed. So which means that set contains only unique elements. So even if you try to replicate the elements or repeat the elements, the set is just going to remove them and retain only the unique elements. Okay, so if you have a list, tuple or a string where you want to remove the duplicates, just you can convert it to set. Okay, so let's say I have a list. Okay, so if I have a list something like 1, 2, 3, 2 and 3, so I have a list, so I have enclosed this in between square braces, which means that it is a list. So now if you want to remove the duplicates inside this list, of course there are other methods to remove duplicates, but you can simply write or you can simply convert them to set, and you can see that you have removed the duplicates, okay, just by converting it to set. And then if you want to convert it back to list, right, you can simply write list of set of that list, so it will come back as a list. Okay, and then you can also remove the duplicates from the string as well, right? You can do the same thing with the strings. So when I have a string something like A, B, C, D, A and B, so I want to remove the duplicates inside this string, so I can simply convert them to a set and it is going to remove the duplicates. Okay, so if I want to convert it back to string, so you can do something like empty string dot join and pass this set, and it will come back as a string. but then the order is lost because the set is unordered object. So that's one disadvantage of using the set to remove duplicates from your string. So the order will be lost, is what I'm trying to say. So if you want to check if an item exists in the set, you can directly write an if statement on the set. So I'll declare a set1 equal to 1, 2, 3 and 4. Okay, so you can, if you want to check if an item exists inside your set, you can directly write an if statement. So I'll write if 2 in set1, I am going to print 2 is present in set 1. Okay, so since 2 is actually present in our set, it is going to print the statement. Okay, the sets support some of the functions such as union, intersection, and also difference, and also there are various other functions that a set supports. So let us try to see an example of each of them. So let me define a function here, two sets here. So I'll define set1 with the values 1, 2, 3 and 4, and set2 with values maybe 5 and 6. Okay, so I have declared two sets. So in this example we want to understand what does this union method going to do. So when I say set1 dot union of set2, okay, so what happens is it is going to return a set which contains all the elements from set1 as well as set2, and of course it will be unique elements. So it's going to combine the elements of set1 and set2 and return as a new set. Okay, so now when I execute this, you see the result is 1, 2, 3, 4, 5, 6, which is just the combination of all the elements from set1 and set2. Okay, so now let's look at the example of intersection of sets. So let me define two sets again here. So I'll define 1, 2, 3, 4, and in the second set I'm going to define maybe 3, 4, 5 and 6. Okay, so I have two sets here. So now I'm going to write something like set1 dot intersection of set2. So what do you think this line is going to return? So if you remember what intersection is, it's basically the elements that are common between these two sets. So what are the elements that are common between these two sets? So it's basically 3, 4 and 3, 4. So these two are the elements that are common between the two sets. So that is what it's going to return. Okay, so when I execute this, you will get the value or a set which contains the elements that are common between the two sets. Okay, so now let us look at the difference function as well. So let's take the same example here, and now instead of intersection we want to find out the difference between two sets. So when I say set1 difference set2, okay, what it's going to return is it's going to return back set1, but it's going to remove the elements from set1 which are common or which appears in set2 as well. So it has to basically return 1, 2, 3, 4, which is set1, but then the two elements in set1 also appear in set2, which is 3 and 4. So 3 and 4 will be removed from set1, and what we get as output is 1 and 2. So when I execute this, you'll get 1 and 2. Okay, so there's a function to find out if a set is a subset of another set. Okay, let me try to show an example here. I'll say set 1 equal to 1 2 3 4 and set 2 equal to 3 and 4. So now I'll write a statement set 2 dot subset of set 1. So when I write set 2 dot subset set 1, what I'm trying to ask is whether set 2 is a subset of set 1, or in other words, whether the elements of set 2 are present in set 1, or all the elements in set 2. I'm just asking all the elements of set 2 are present in set 1. Okay, so it's actually true. Set object has no attribute. It is subset, so it's going to return true or false, right? So when I execute it is true. It's because set 2 contains only those elements. So yeah, set 2 contains only those elements which are present in set 1. So that is what the meaning of subset is. Okay, so now there is another function called superset. It's basically similar to. So now let us check another example here. Let's say 3 4 and 5, and I want to check whether 3 4 and 5 is a subset of 1 2 3 4. What do you think the answer is? So the definition is that set 2 is a subset of set 1 if all the elements of set 2 appear in set 1, or in other words, set 2 contains only those elements that are present in set 1. So we have an element 5 which is not present in set 1. That's why set 2 is not a subset of set 1. So you're going to get false. Okay, now there's also a function called superset. It's basically just like the subset. It's just the reverse way of asking, right? So when I say in this way, you're checking set 1 is a superset of set 2. So when I say set 1 dot is superset of set 2, I'm just asking whether set 1 is a superset of set 2, or in other words, I'm just asking if set 1 contains all the elements that are present in set 2. Okay, if set 1 contains all the elements that are present in set 2, then set 1 is a superset of set 2. So when I execute this, I should get true because set 1 contains all the elements that are present in set 2. All the elements that are present in set 2 is 3 and 4, so which is also present in set 1. That's why set 1 is a superset of set 2. So let me try another example here. When I say 3 4 and 5, do you think set 1 is a superset of set 2? The answer should be false, because by the definition, set 1 is a superset of set 2 if set 1 contains all the elements that are present in set 2. So set 1 should contain all the elements that are present in set 2. So all the elements that are present in set 2 is 3 4 and 5. Out of these elements, only 3 and 4 are present in set 1 and 5 is missing. So that is why set 1 is not a superset of set 2 in this case, and when you execute this, you'll get the answer as false. Okay, now there's a function called add to, if you want to add new element to the set. So when I say set 1 equal to maybe 1 2 and 3, okay, and then let me try to show the add function. So the add function accepts a parameter which you want to add. Okay, so set1 dot add, it will add the number 4 into our existing set. Okay, so now when I check the value of set1, it contains 1, 2, 3 and 4. And to remove an element from the list, there is a function called discard. Okay, so when I say set1 dot discard, and if you want, so it accepts a parameter or an element that you want to remove from your set. So when I say 4, so it's going to remove 4 from our set, and the final set should contain only the elements 1, 2 and 3. So let us verify that. So we have only 1, 2 and 3.